Okay, our next presenter is Afnan Shazwan Nasarudin, who is a fourth-year bioagricultural sciences and pest management student. He's a PhD student in plant pathology. And he knew he wanted to study plant pathology when he learned about it in his undergraduate senior course at the Rochester Institute of Technology. He hopes to work on diseases affecting crops of international importance and contribute to public science communication. And he needs to speak to one of our earlier speakers because he completed his first full trail marathon last year in October. So the title of his presentation is The Chemical Radar, Bacterial Chemotaxis.
Each year, at least $400 million of potato losses occur in the United States. What causes such devastating losses of potato? Soft-rot bacteria, specifically a bacterial family known as Bacteriaceae. Soft-rot bacteria can destroy the insides of potato stems and tubers, turning them into mush. These bacteria are notorious for persisting in the environment. Currently, there is no sustainable chemical management for this disease. The threat that soft-rot bacteria pose to the potato industry was worsened in 2015 when multiple outbreaks of soft-rot occurred across the United States. A prominent characteristic of soft-rot bacteria is that they have legs all over their bodies. These legs are called flagella. Now, imagine yourself as this tiny bacterium in a vast and hostile environment. How would you even move anywhere? How would you find food? What if I tell you that bacteria have a chemical radar? It's called chemotaxis. Chemo refers to chemicals, and taxis refers to directed movement in response to something. In this case, chemicals. You know, when you are hungry and you smell something delicious and you start to search around and walk towards it? In a similar way, chemotaxis senses the chemicals in the environment and coordinates all the flagella to rotate in the same direction, forming a bundle that allows the bacterium to move or run in a straight line. My research focuses on how chemotaxis is regulated in soft-rot bacteria. I tested a total of 25 chemicals found in plants on 19 soft-rot bacterial strains to determine which chemicals they are attracted to. I found that all of them were attracted to one chemical known as malic acid. To my surprise, soft-rot bacteria cannot use malic acid as a food source. However, malic acid is abundantly found in potato plants and is generally secreted by plant roots. This suggests that soft-rot bacteria use malic acid to find their plant host. My findings opens a possibility for future research in using chemotaxis against bacteria for sustainable management of disease. For instance, using malic acid to bait soft-rot bacteria away from potato plants, therefore reducing potato losses so that we can all continue to enjoy our favorite potato dish for many years to come. In my case, that's French fries. Thank you.